Hello, today we are going to learn trigonometric integrals. In this lesson, we are going to follow two types of problems. The type 1 of the problem is this. In type 1, we integrate powers of sine and cosine. All right, that is integration sine mx times cosine nx. Okay, so that's the first type of the problems that we're going to discuss. We divide this type of problems into three parts. In the first part, we consider m is odd, and in the next case, we consider n is even, and thereafter we let me repeat. M is odd, and in the next case we consider n is odd, and then in the last case we consider both are even. Okay, this is the first case is this is odd, the second case is that is odd, the third case is both are even. All right, let's move to the first case. Case 1, where m is odd. So I'm going to give you a method here, so you could use that method and find the solution easily. The method is this. Save one sine factor and use sine square x equals 1 minus cos square x for the rest of the factors. All right, let's discuss an example. You can understand this clearly. Example 1. Let's say you are going to integrate sine 3x times cosine 2x. All right, so this is sine. Here, first thing you have to check is whether this is odd. You see that is odd. So that is case number 1. Then what you do? You start with sine 3 to the sine to the power 3. Here it says you have to save one sine factor. That means you write this to be sine x times, and then write the remaining factors, which is sine square x. All right, and then use this identity for the rest of the factors. That means you have sine square x here, you're going to use that identity for that factor. And then you write this to be sine x times 1 minus cos square x. All right. So this equals sine 3x, sine x to the power 3. Now I'm going to substitute that into the given problem. The given problem is this. You have integration sine 3x cos square x dx. Then I write this as sine x 1 minus cos square x times cos square x dx. Alright, now what I'm going to do is I'm going to use u substitution. You have done this part, you have done that part. You just save one sine factor and then wrote the rest of the factors like that. Next step is, then you have to use the substitution u equals cos x. Okay, let me include the next step. Let me get more space here. This is step number 1. The next step is then use the substitution u equals cosine x. Okay, now I'm going to do that substitution. For here I see cosine here, cosine there, so I could use that substitution. Right. I'm going to substitute u equals cosine x. You learned substitution method early. We have to change the variable x to variable u because your new variable is u. First of all, let me differentiate u with respect to x. Here you get minus sine x. Let me solve this for dx. What you get is minus du over sine x equals dx. Alright, you could plug that dx here. Alright, then you can just substitute everything. I keep the sine x as it is. Alright, I keep that sine x as it is because I see the sine x can be cancelled. I write that sine x and then I write 1 minus cos x is u, that means u square. For this cos x you put u square. For dx you write minus du over sine x. Now you see that this sine x can be cancelled by that sine x. So what you have here is integration 1 minus u square times u square du. Alright, so this is the new problem we have. We started with a complicated problem. Now we have a simple problem. Now you have to integrate that. Okay, this is a simple integration. First of all, you have to remove parentheses. You write u square minus u to the power 4 du. Here you are using the power rule. You write minus u to the power 2 plus 1 over 2 plus 1 minus u to the power 4 plus 1 over 4 plus 1. Alright, put a constant plus c. Because this is indefinite integration. See, this is indefinite integration. You don't have limits, so you should put a constant. Don't forget to put that constant. If you have forgotten the integration rule here, it is the power law for integration, which is if you have something like integration of x to the power n dx, the integration of that one should be x to the power n plus 1 over n plus 1. So this is the formula that I have used here. Now I have to simplify this. This is minus u to the power 3 over 3 minus u to the power 5 over 5 plus c. So you multiply by negative 1. So you get u to the power 5 over 5 and then minus u to the power 3 over 3 plus c. Alright, some student might think this as the final answer. No, this is not the final answer. The reason for that is you have to bring the solution to the original form, original variable. Okay, so the original variable is that. Original variable should be x. So you can plug back u. U should be cos x. For this you could write cos 5x over 5 minus cos 3x over 3 plus c. You can see now cos 3x is a factor. You just factorize cos 3x and then you write cos 2x over 5 minus 1 over 3. That's the constant. So this is the solution. Alright, so this is the solution for the first problem. Alright, that is case number 1, where m is odd. Now just move to case number 2, where n is odd. Case 2, where n is odd. Alright, so this is the method for this case. Save one cosine factor of cos nx and use cos square x equals 1 minus sine square x for the rest of the factors. Alright, then the next point, then use the substitution u equals sine x. Alright, so here the method is kind of similar to the previous method. Only difference is we save one cosine factor here. Previously we were saving a sine factor. Now we are saving a cosine factor, and then we use this identity for the remaining terms, remaining cosine terms. Okay, so let's discuss one example so you can understand this. Example number 2. I'm going to integrate cosine 5x dx. Now you have to check whether n is odd. Yes, that is true. This is odd. Alright, so you write cos to the power 5 as you save one cosine factor and write the remaining factors. Okay, then cosine x. For the remaining factors you just use that identity. That identity is 1 minus sine square x to the power 2. I use that identity for the remaining factors. Alright. Okay, now just plug that back to the original problem. So what you have here is that, and then this equals cosine x 1 minus sine square x square dx. Right, the next point says use the substitution u equals sine x. Right, so I'm going to use that substitution. Our substitution here is u equals sine x. Alright. So then you have to replace all the x values, all the x's with u's. That is, u is the variable. You have to replace variable x by variable u. First of all, I'm going to differentiate u with respect to x, which is cos x, and then I'm going to solve that for dx. Then I write du over cos x equals dx. All right. Now I'm going to plug that dx into the original formula. Integration. I just keep this cos x as it is because I see that this cos x can be cancelled. And for the remaining terms, I'm just plugging u equals sine x. So this will be minus u square. For dx, I write du over cosine x. Now I see that this can be cancelled with that. All right, so rewrite the new problem, which is 1 minus u square du. So this is an easy problem now. You started with a complicated problem. Now you have an easy problem right here. All right, so again the power rule. Again you are going to use the power rule. All right, first expand this problem. So I write 1 minus 2u square plus u to the power 4. That is the expansion of that square. And then I use the power rule. Here 1 is same as u to the power 0. So I write that as u 0 plus 1 over 0 plus 1. Here minus 2. U 2 plus 1 over 2 plus 1 plus u 4 plus 1 over 4 plus 1 and the constant. Alright, so you write this du minus 2 over 3 u to the power 3 plus u to the power 5 over 5 plus c. Alright, you can see u is a factor. You can take one u out and then you have 1 minus 2 over 3 u to the power 2 plus 1 over 5 u to the power 4 plus c. Okay, now the thing is this, you can keep variable u because that is the variable you introduce. Now you have to bring back the original variable, which is u equals sine x. Alright, so you write this as sine x 1 minus 2 over 3 sine square x plus 1 over 5 sine 4x plus c. Okay, so that is the solution. Alright, so we discussed two problems. The first problem for case 1 and the second problem for case 2. Now I'm moving to case 3. In case 3, both m and n are even. Alright, so this is the method here. Now we are going to use half angle identities. If you can remember your trigonometric class, when you were learning Calc 1, you learn half angle identities. So let me write the half angle identities. Use the following half angle identities. Those half angle identities are sine, square x equals 1 minus cos x over 2. Cos square x equals 1 plus cos, I'm sorry, I made a mistake. These should be 2x. Here this should be cos 2x over 2. Alright, so let's move to the examples. Let us discuss the first example. That is example 3 in the section. Let's say you are given a function like this that you have to integrate. Sine square x times cosine square x. Okay, sine square x, cosine square x. Now you have to check whether the powers are even. Of course, this is even, that is even. Alright, both are even. Now you have to use the half angle formula. So you write this as integration. For cosine square, you could use that formula. That is 1 minus cos 2x over 2. And for this cosine square, you write 1 plus cos 2x over 2, and you write dx. Now you remove parentheses. If you remove parentheses, you could write this is half, that is half, it will be 1/4, and then you multiply this with that, you will get 1. You multiply this with that, you get plus cos 2x. If you multiply this with that, you will get minus cos 2x. If you multiply that with that, you will get plus cos square. I'm sorry, to minus. Let me put minus here. I'm sorry. Let me put minus there. It should be minus. See, it is here, it is minus, it is plus. So plus minus is minus cos square 2x dx. Alright, now you can see this cos 2x can be cancelled with that minus cos 2x. So I rewrite this as 1/4 integration 1 minus cos square 2x. Alright, so this is the problem we have. Alright, now we're going to integrate this. This integrand has two parts. First part is 1, the other part is minus cos square 2x. First integrate 1 with respect to x, and then integrate cos square 2x with respect to x. Alright. Good. Alright. Integration of that one is straightforward, but the integration of this part is not straightforward. Right, let me take that one as a new equation. I take this as a, and let's consider this as equation number 1. Now I'm going to solve a separately and then plug back. Okay, this is a. I have to integrate cos square 2x dx. Alright, if you can remember, the integration of this one is there's no formula available to integrate that. There's no formula available to integrate that. For this, what you could do is you could use half angle formula again. See, you could use that half angle formula again. Alright, so I'm going to use that half angle formula for this integrand. Here I have cos square 2x. Alright, so I'm going to use that one here. Let's say you have cos square 2x, then what's the modification of this function equation? If you have cos square 2x, then this is actually 1 plus cos 2 times 2x over 2. Alright, you can understand that if you had x here, you have 2x here. If you had 2x here, then there should be 4x here. 2 times 2 is 4x. Okay, keep that in mind. If you had x here, it is 2x here. If you had 2x there, you should get 4x here. Okay, let me get those extra parts out. Then what I'm writing here is integration 1 plus cos 4x over 2 dx. Alright, then this equals, you could take half out and you could integrate 1 with respect to dx, and then you could integrate 4x with respect to dx. Right? The integration of 1 should be just x, and integration of cos 4x should be sine 4x over 4. You have done this in calc 1, and then you have to add a constant. I'm not going to add the constant here. Why? I'm going to add one constant after simplifying this equation. All right, so I don't put a constant here. I will put one constant at the end for everything. So let me get that constant out, and let me denote that as 2. Actually, this is the integration of cos square 2x. I plug, substitute 2 into 1. If I substitute 2 into 1, what I get is integration of the given problem, which is right here, sine square x cos square x dx, that equals this part, integration of that, 1/4 integration of 1, and then part a, this a is actually that part, so you write that as plus, I'm sorry, it should be minus here. It's minus, not plus, it's minus half x plus sine 4x over 4. Alright, then I have to integrate this part, integration of 1 with respect to x, that is actually just x. Integration of 1 with respect to x is x, so I directly put x here. Okay, this is x. Alright, so now this is the solution. I have to simplify this. Let me simplify this. So this is 1/4. This is x minus half of x minus 1/8 sine 4x. Okay, then I am multiplying by 1/4. Now before multiplying by 1/4, let me simplify these two. If you simplify those two, what you get is 1/4 x over 2 minus 1/8 sine 4x, and then multiply by 1/4, then you get x over 8 minus 1/32 sine 4x. Now this is the time to put a constant. Okay, at last I put a constant, so that is the solution of the problem. All right. right, so this is the case where you had even powers, even power here, even power there. That is case number 3. So this is a simple example. Just read the example, you will be able to understand it. Now we are going to move to the next type. This is type number 1. This is type number 1, where we discuss 3 cases. Case 1 where m is odd, case 2 where n is odd, case 3 where both m and n are even. Alright, that is type 1. Type 1 had 3 cases. Now move to type 2. Let me take these out. Now just discuss type 3. Sorry, type 2. Type 2. All right. Type 2 is integrating power of tan x and secant x. All right. Consider the case, the type here is integration tan mx, tan x to the power m, secant n to the power, secant x to the power n. Okay, this is the new case we have. So the new type we have. All right. So here also we are going through cases, case 1, case 2, like that. So first of all, discuss case 1. Case 1, we consider n is even. Okay, the good thing is we have a method. Since we have a method, so you can easily use the method. This is the method. First point of the method, save a factor of secant square x. Save a factor of secant square x. Okay. And use secant square x equals 1 plus tan square x for the rest of the factors. All right, the next point, then use the substitution u equals tan x. Okay, let's move to example number 4. You can understand these materials very well if you go to if you just discuss an example. So example 4, let's say you are given integration tan 4x secant (4x). All right. Now just check whether n is even. Okay, this is n, which is even. Now we're going to use the given method. So you write secant 4x as secant square x. You have to save square of secant x, and for the remainder you have to use that identity. For secant square x, you write 1 plus tan square x. Alright, then plug that into the given problem. So this should be integration tan 4x. For secant 4x, I write secant square x 1 plus tan square x dx. Alright, now I have to use the substitution u equals tan x. Here u equals tan x. So I have to differentiate this first. Differentiate this with respect to x. So that is secant square x. Then I solve that for dx. This is, I'm sorry, that should be dx. Alright, now just plug u equals tan x. Here tan to the power 4, for that I write u to the power 4. Here secant square x, I don't write anything there because I know this can be cancelled. And then I write 1 plus tan square x should be u square. And then for dx I write du over secant square x. Now I see that this can be cancelled with that. Then I write this as u to the power 4 1 plus u square du. Alright, now it's a simple problem. It's a very easy problem. That's the power rule for integration. So first you remove the parentheses. For that you just multiply this one by u to the power 4. You get u to the power 4 plus u to the power 6 du. And the integration of that one should be 4 plus 1. 4 plus 1 here, u to the power 6 plus 1. 6 plus 1 here, and a constant. So this will be u to the power 5 over 5 plus u to the power 7 over 7 plus constant. Alright, now you can see u to the power 5 is a factor. So you could factor u to the power 5 out. So this is 1 over 5 plus u to the power 2 over 7 plus c. Okay, but this is not the solution yet. Why this is not the solution? You have to plug back for u. If you plug back for u, your u should be tan x. Okay, so you have to plug back for u. So you write tan 5x, tan to the power 5, inside parenthesis 1 over 5 plus tan square x over 7 plus c. So this is the solution. Give me a second. Alright, so that is the solution for this problem. Let me take these extra lines out. Alright, so this is case 2 of type 2. Case 2 of type 2, and then we move to case 1 of type 2. Now we move to case 2 of type 2. In case 2, we consider m is odd. Case 1 was n is even. Now case 2 is m is odd. Alright, so you have a method. First of all, I'm going to write the method. Save a factor of secant x times tan x, and then use tan square x equals secant square x minus 1 for the rest of the factors. Point 2, then use the substitution u equals secant x. Alright, so this is the next case, case number 2. Directly move to an example. This is, I think, example number 5. Let's say you are given this integration tan to the power 5x times secant to the power 7x dx. Alright, you have to check whether m is odd. See, this is m, which is odd. Alright, now we're going to use the method described here. You write tan 5x. You save a factor of sine x, secant x tan x. Give me a second. Let me put everything together. What I would do, I just save a factor of secant x tan x. That means I write secant x times tan x, and then write the rest of the terms. The rest of the terms should be tan 4x secant 6x dx. Okay, I saved one factor. That is step number 1. This point, first point, I saved one secant x and tan x term, and then use this identity for tan square. Let me take these lines out, and what I would do, I write secant x times tan x, and for this tan to the power 4, I use that identity. That means I write this as secant square x minus 1 to the power 2 times secant secant to the power 6 dx. Alright, so what I have done is I have used this identity when I move from tan to the power 4. What I'm saying is I use this identity 4 tan to the power 4. All right, so now I have to simplify. Before simplifying, I have to use the substitution, and now the substitution is u equals secant x. All right, so I'm going to substitute u equals secant x. First thing is I have to differentiate u with respect to x. If you can remember, the derivative of secant is secant x tan x. Secant x times tan x. I solve that for dx. So I write du over secant x tan x equals dx. And I'm going to plug this one into that equation. Let me rewrite the previous equation or the previous problem with the substitution. The substitution is u equals secant x. So I plug u for every time I see secant x. So here I write. For this part I don't write anything because I see this part can be cancelled with that. So I just write secant x tan x and keep it separately. For this secant, I plug u square minus 1 square. For this secant 6, I plug u again. This is u to the power 6. For dx, I write du over secant x tan x. Alright, now I can see this whole thing can be cancelled by that whole thing. Now the problem will look like u to the power 2 minus 1 to the power 2 u to the power 6 du. Okay, now you see this is a simple problem. This is a simple problem. Okay, before solving that problem, let me delete these lines and arrows. Alright, now again it's a very simple problem where you use the power rule. First of all, I will just expand. Then this will be u to the power 8. I'm sorry, there's a square. First of all, I have to eliminate that square. For that, I write u to the power 4 minus 2u square plus 1 u to the power 6 du, and then this is u to the power 10 minus 2u to the power 8 plus u to the power 6 du. Now I'm gonna integrate. This will be u to the power 10 plus 1 over 10 plus 1 minus 2 times u to the power 8 plus 1 over 8 plus 1 plus u to the power 6 plus 1 over 6 plus 1 plus c. Right, this is same as u to the power 11 over 11 minus 2 over 9 u to the power 9 plus u to the power 7 over 7 plus c. Now you can see u to the power 7 is a factor, so you could factor that out. I factor u to the power 7, so here what you get is u to the power 4 over 11 minus 2 over 9 u to the power 2. Since I am factoring u to the power 7, here I get 1 over 7 plus c. This is not a solution because you have to plug back for u. Our u was secant x. Our u was secant x, so you have to plug back for secant x. Then this will be secant 7x secant 4x over 11 minus 2 over 9 secant square x plus 1 over 7 plus c. Alright, so that is the solution for that problem, problem number 4, no, problem number 5. Okay, here we are discussing type 2. We discuss case 1 where n is even, case 2 where m is odd. Now we move to case 3. Case 3 is neither n even nor m odd. Neither n is even nor m is odd. All right. The issue here is no clear method available for this case. For case 3, no clear method available. Because of that reason, I'm gonna skip case 3 of type 2. Okay, I'm gonna skip this case. So you don't get any exam problems in your exams, or you don't have any problems associated with this in this course, because the method here is very uncertain. All right, so let me put a note on that. Here the method is not clear. We may need to use identities integration by parts, etc. Okay, so thus we skip this case. Okay, so we skip this case. All right, so that is the end of the section. In this section we are discussing trigonometric integrals. We discuss type 1 with 3 cases, and then we discuss type 2 of the problems with 3 cases. Actually we skip the third case because no clear method is available. So that's all for today. Thank you very much.